All right, so get this. Listener sent in some research on dark energy and black holes, and wow, this is wild.
Yeah.
Yeah, we've got some articles from space.com, the University of Michigan, and Imperial College London,
Okay.
and they all seem to be pointing to this like potential link between these two like cosmic heavyweight,
Yeah.
black holes and dark energy.
Right.
Like, what if black holes are the source of dark energy?
Yeah, that is mind-bending, isn't it? It really is.
Right. Keeps you up at night.
It really is. We're talking about the very fabric of the universe here.
Yeah.
Think about it.
Yeah.
Dark energy is this mysterious force that's like pushing everything apart, causing the universe to expand at an accelerating rate.
Yeah.
And black holes, well, we used to think of them as these cosmic vacuum cleaners just sucking up everything in their path.
Right.
But this research is suggesting they might be playing a much more creative role.
Okay, so how do we even begin to wrap our heads around this? I mean, black holes and dark energy just seem like they'd be at odds with each other.
Yeah.
One's all about like intense gravity, and the other is pushing everything apart.
Right, exactly. And that's what makes this theory so intriguing, right?
Yeah.
It challenges our fundamental understanding of both black holes and dark energy.
Yeah.
One of the key pieces of evidence comes from observations of distant galaxies.
Oh, okay.
Astronomers have been studying supermassive black holes at the centers of these galaxies.
Right.
And what they've found is that these black holes are growing way faster than they should be if they were just swallowing up matter or merging with each other.
So something else is going on, something we haven't been able to explain with our current models.
Right.
And that's where the dark energy comes in.
That's the idea.
Okay.
Researchers are proposing that black holes might be directly linked to the fabric of the universe itself.
Okay.
It's a concept called cosmological coupling.
Cosmological coupling.
As the universe expands, black holes grow, and the amount of dark energy increases. Like they're all dancing together, influencing each other's movements.
Wait, so you're saying that instead of just gobbling up matter,
Yeah.
black holes might actually be absorbing dark energy from the expanding universe.
That's one of the hypotheses.
And as they do that, they contribute even more to the expansion.
Right.
Oh.
And it gets even weirder when you consider what this might mean for the inside of a black hole.
Okay.
We often hear about the singularity at the heart of a black hole.
Right.
This point of infinite density where all the laws of physics break down.
Yeah.
But if black holes contain dark energy, which has this repulsive force,
Right.
it could actually counteract the intense gravity at their core.
So are you suggesting that black holes might not even have singularities?
Yeah.
That this dark energy could somehow smooth things out?
It's a mind-blowing possibility, isn't it?
Yeah.
And it's one that has huge implications for our understanding of how black holes work,
Right.
and potentially even for resolving some of the biggest mysteries in physics.
Okay, I'm hooked.
Yeah.
We need to unpack this further. Where do we start?
Well, let's take a closer look at the evidence from distant galaxies.
Okay,
I think that's a good place to really grasp the scale of this discovery.
let's do it.
Okay, so picture this. You're looking at a galaxy billions of light years away.
Okay.
The light we see from it is ancient, a snapshot from a time when the universe was much younger.
Oh, cool. So like a cosmic time machine.
Exactly.
So what are we seeing when we peer back that far?
What's fascinating is that when astronomers observed these ancient galaxies, they found something unexpected. The supermassive black holes at their centers were much smaller than they should be, based on our current understanding of how black holes grow.
So like these baby black holes weren't keeping up with their growth charts.
Exactly.
Huh.
And then when they compared these ancient black holes to the supermassive ones we see in nearby galaxies, which are much older,
Right.
there was a huge size discrepancy. The nearby black holes were significantly larger than they should have been,
Okay.
if they had only grown by absorbing matter or merging with other black holes.
Okay, so something doesn't add up.
Right.
The rate of growth is just way too high.
Yeah.
Is this where the theory of black holes absorbing dark energy really starts to gain traction?
It is. The researchers behind this theory found that the growth of these supermassive black holes correlates remarkably well with the expansion of the universe. It's as if they're growing in sync, fueled by the very force that's pushing everything apart.
Now, how did they actually measure this growth, this correlation?
Right.
We're talking about objects that are billions of light years away.
This is where some incredible technology comes in.
Okay.
The Dark Energy Spectroscopic Instrument, or DSI for short.
DSI.
It's essentially creating a 3D map of the universe,
Oh.
allowing us to measure the expansion with incredible precision.
So DSIZ is like the ultimate cosmic cartographer then.
Right.
It's mapping out not just where things are, but how they're moving and changing over time.
Precisely. And the data from DSI seems to support the idea that the density of dark energy is increasing, which, according to this theory, would be directly related to the growth of black holes.
Okay, so we have these observations of distant galaxies.
Right.
The unexpected growth of supermassive black holes.
Yeah.
And then we have data from DSI that is suggesting an increase in dark energy density.
Right.
It's all starting to come together, isn't it?
Yeah.
But I still keep coming back to this idea of the singularity.
Okay.
If black holes contain dark energy,
Yeah.
does that really mean there's no point of infinite density at their core?
That's the big question.
Yeah.
And one that physicists are still grappling with.
Okay.
The traditional view of a singularity.
Right.
Is that it's a point where gravity becomes so strong that it crushes everything down to an infinitely small point.
Right. A point where our current laws of physics just break down.
Exactly. But if black holes are indeed absorbing dark energy and growing in sync with the universe,
Right.
it suggests that the singularity might not be as singular as we once thought.
So instead of this point of ultimate collapse, there might be something else.
Right.
Something, well, less singular.
It's possible. Perhaps the dark energy within a black hole creates a sort of counter pressure,
Okay.
a force that prevents the complete collapse into a singularity.
So maybe it's not a point of infinite density,
Yeah.
but rather a point of intense density
Right.
balanced by this repulsive force of dark energy.
That's a very intriguing way to think about it.
Yeah.
And it's one of the reasons why this theory is causing such a stir in the world of cosmology. It has the potential to reshape our understanding of black holes,
Yeah.
dark energy, and perhaps even the very nature of gravity itself.
This is wild. We've come a long way from black holes just being cosmic vacuum cleaners, haven't we?
We have, and there's still so much more to explore.
Right.
For example, if black holes are indeed fueled by dark energy,
Yeah.
what are the implications for the ultimate fate of the universe?
Ooh, good question. Does this mean the universe will just keep expanding forever?
Yeah.
Or could something else happen?
Well, let's dive into those possibilities.
So, okay, we've established that black holes might be fueled by dark energy.
Right.
And that has like some pretty major implications for how we understand the universe.
Yeah.
But where do we go from there? What happens in the long run?
Well, that's a question that has cosmologists scratching their heads.
Okay.
There are a few different scenarios, all depending on like the nature of dark energy
Right.
and how it continues to interact with black holes.
All right. Lay it on me. What are the options?
One possibility is that the universe keeps expanding faster and faster, leading to what's called the Big Rip.
The Big Rip.
Yeah.
Doesn't sound too pleasant.
No.
What would that look like?
Essentially, the expansion becomes so powerful that it overcomes all other forces,
Oh, wow.
even the forces holding atoms together. Galaxies would be torn apart, stars would be shredded,
Wow.
and eventually, even matter itself would be ripped apart.
So not just things moving away from each other, but everything disintegrating on like a fundamental level.
Right.
That's a pretty dramatic ending.
It is a dramatic scenario, yes, but it's important to remember that it's just one possibility.
Okay.
Another scenario is the Big Crunch, where the expansion eventually slows down and reverses.
So instead of ripping apart, everything collapses back in on itself.
Exactly.
Like a cosmic rewind.
Yeah, it would be like the universe playing a giant game of cosmic expansion and contraction.
Right.
And then, of course, there's the possibility that the expansion continues at a more or less steady rate,
Okay.
eventually leading to a heat death.
Okay, so we've got the Big Rip, the Big Crunch,
Right.
and the heat death.
Yeah.
That's a pretty wide range of outcomes.
It is.
It seems like the fate of the universe really hinges on like what this dark energy is all about and how it interacts with black holes.
Absolutely. And it's not just about the grand fate of the universe either.
Right.
This research has implications for so many other areas of astrophysics.
Okay.
You know, understanding the connection between black holes and dark energy could help us figure out how galaxies form and evolve,
Yeah.
how matter is distributed throughout the universe, and even shed light on some of the most fundamental laws of physics.
It's amazing to think that something as seemingly destructive as a black hole could actually be playing such a vital role in the universe.
Yeah.
I mean, we've gone from thinking of them as cosmic vacuum cleaners
Right.
to potentially the engines of cosmic creation.
Yeah.
It really shifts your perspective, doesn't
It
it?
does. It highlights the fact that we're still just scratching the surface when it comes to understanding the universe.
Right.
Every new discovery opens up more questions, more possibilities, more mysteries to explore.
And that's what makes it so exciting, right?
Yeah,
This constant sense of discovery and wonder.
right.
We're lucky to be living in a time where these kinds of breakthroughs are happening.
Absolutely. Who knows what other mind-boggling discoveries await us as we continue to peer deeper into the cosmos.
Well, I, for one, can't wait to find out. So for everyone listening, keep those minds curious, keep asking questions, and keep looking up at the stars. You never know what secrets they might reveal next.